Okay, it's Mr. Cooper again. I hope you are okay and healthy. And I hope you had a go at the ratio work I set at the beginning of the week. I'd like to go through the 3 challenge questions that I set you. Remember, the answers to the main set of questions were on the second page of that sheet. So here we've got 3 people sharing some money, but they give you the ratio in 2 bits. So Alfie and Bertie, they share their money in the ratio 9 to 5, but Bertie and Charlie share their money in the ratio 2 to 1. And what I want to do is combine these 2 ratios into 1 ratio, so I know how Alfie, Bertie and Charlie shared it. And well done, I'm sure some of you would have got this. The secret lies a bit like a common denominator problem. What we need to do is look at what both ratios have got in common. Bertie features in both. So what we need to do is to change both ratios so that this number becomes the same. And the first number in the 5 and the 2 times table is 10. So I can double that to make it 10, and I need to therefore double the 9 to make that 18. And I need to multiply this by 5 to make it 10, and therefore I need to multiply this by 5 as well, because just with a fraction, with a ratio, you can multiply or divide by anything you want, as long as you do both numbers by the same thing. Right, now look, this is the same. So what I can now do is write it as a single ratio. So I'm basically taking the 2 ratios and sliding them together, and the 10s overlap. So what that shows me is that this money gets shared, and 18 plus 10 is 28, 33 shares. Now, I can't draw my boxes, 18, 10, 5, that would be too many, but I've got £46, so I know that £46 divided by 33 is, not divided by 3, divided by 33, sorry, 46 divided by 33 is £1.39 when I round it. And therefore Alfie will get 18 times that. £1.39 times 18. So he gets £13.90. This was a rounded value. Sorry, I've chopped that off. There you go. This is a rounded value, but there we go. Okay, here's the second one then. So we've got Dylan and Eli, 7 to 3, we're told that here, and Dylan to Fabian, 4 to 5. Now this time they've both got Dylan in common, but can you see what the problem here is? We've got D here and here, whereas in the last one the 2 D's are in the middle, and there's no problem with it being like the way around, but I just like things to be the same, so what I'm going to do is just change that ratio around. All I've done is just flipped it over, and then that ratio can stay the same. So I've got my 2 numbers in common in the middle, so I'm looking for the first number in the 7 and the 4 times table, that's 28. So that was multiplying it by 4, so that's going to become 12. And to make that into 28, I multiplied by 7, so that needs to become 35. So now I can write my single ratio E, D, F, which is 12, 28 and 35. Now, Fabian gets 21 more sweets than Dylan. So Dylan gets 28 shares and Fabian gets 35 shares. So Fabian's getting 7 extra shares. So his 7 extra shares, 28 to 35, that's 7 extra shares, that's 21 sweets. We're told he gets 21 extra sweets. So each share must be 3 sweets. Eli gets 12 shares. So 12 shares is going to be 12 times 3, which is 36. So 36 sweets is the answer to the question. How many does Eli get? Now, don't be fooled by this third question being only 2 marks. I think this is really hard. So this time, the problem was that the ratio was a real mixture. So we're told here that the ratio of games that they won to those they did not win, so that means the ones they either drew or lost, was 9-7. And this goes to what I was going to cover in this next lesson. 9 and 7 is 16 shares altogether, so what I know is that 9/16 of the games they won and 7/16 of the games they either drew or lost. Okay, this second ratio says the games they lost to the games they didn't lose, which is either they won them or they drew them, is 1-7. So that means they lost 1/8 of their games and they won 7/8 of their games. Now, if I look at these two facts here, they drew and lost 7/16 of their games. They lost 1/8 of their games. Now, if I write 1/8 as 2/16 by doubling the top and the bottom, if they drew and lost 7/16 of their games, but lost 2/16 of their games, it must mean that they drew 5/16 of their games. So, if I summarise, I know they won 9/16. I know they lost 1/8 or 2/16, and that must mean that they drew 5/16. And alternatively, because I've got the same denominator there, I could write that like this. The ratio of wins to loses to draws is 9-2-5. Now, we don't know how many games they played in total, so I can't add that up, and that's 16, and divide the number of games by 16 to work out how many games each share was. I've got to work backwards here. Well, let's say each share was 1. So that means that they won 9 games, they lost 2 games, and drew 5 games, giving a total of 16 games. What about if each share was worth 2 games? That means 9 times 2 is 18, 4, 10. They could have won 18, lost 2, and drawn 10. That makes a total of 32. What about if each share was worth 3 games? 9 lots of 3 is 27, 2 times 3 is 6, 5 times 3 is 15. That means a total of 48 games. What about if each share was worth 4 games? Well, 4 9s are 36, 4 times 2 is 8, 4 times 5 is 20. That makes 64 games. Now, we're told they played less than 50 games, so can't be that one. But it could be this one. Work out the highest number of games they could have won. Well, it could be any one of these scenarios, so the answer is they could have won 27 games. Well done if you got that right. Okay, so moving on, I want to talk about ratio and fractions today. So let's say we're mixing some paint, and we're mixing 2 colours in the ratio 2:3. 2 parts red, 3 parts blue. So this is a ratio that describes the mixture, but I can also describe that mixture using fractions or a percentage. I've got 5 parts altogether, so I can say that 2/5 of that paint is red and 3/5 is blue. And it's really important you understand why it's 2/5 and 3/5 and not 2/3. I could also use percentages. 2/5 is 40% or 3/5 is 60%. So what I'm doing here is saying what part of the whole is red. 40%, 2 out of 5. And we call that a proportion. So a proportion asks what part of the whole thing. And proportions are written as fractions, percentages, sometimes decimals. What I've got here is a ratio that is comparing one part with another. So a ratio is about comparing parts. So it doesn't say what we've got in total, although we can work that out. What the ratio is doing is comparing the size of the two parts. And being able to flick between the two, between describing a mixture as a proportion, what part of the whole it is, and a ratio is really important. Let's just look at a couple of examples. So here we've got a paint made up of three colours. A quarter of that paint is red, 5/8 blue and 1/8 green. These are proportions, and the question says write that mixture as a ratio. First thing I need to understand is that in order to do that I really want these written with a common denominator, so I'm going to rewrite 1/4 as 2/8, just double numerator and denominator. So now I have got 2, 5, 1. 2, 5 and 1. Needed to get a common denominator to do that, but that's the answer. So that's that example. That's the first example. Here's the second example. We're told here that ratio of people on a particular trip, ratio of adults to children is 2 to 3. And of the children, they are made up of boys and girls in the ratio 3 to 7. What fraction are boys? Well, what you need to firstly say is, okay, let's look at this ratio here. Boys are 3/10 of the children. Okay, 3 parts, 7 parts, 10 parts altogether. So boys are 3/10, girls are 7/10. So that's what fraction of the children are boys. But look at this ratio. Children are 3/5 of the total number of people, aren't they? So children, 3 parts, adults, 2 parts, 5 parts altogether. So the answer to the question is, what fraction of boys is 3/10 of 3/5? And we do that sum by multiplying. Quick check for cross-cancelling. Can't do it. So that's 9/50. Multiplying fractions is easy. 3 times 3, 10 times 5. If it had said what percentage are boys, I would have done exactly the same, and when I'd got to there I would have remembered that percent means out of 100, so it is 18%. Okay, so I've set you a few straightforward questions and then a couple of slightly harder questions. They are attached to the class charts homework. Again, you've got one file, one PDF with the questions, and then another PDF with the answers. This is not work I'm going to take in and mark. It is down to you to keep up, and it's really important that you keep up. And I will post more work for you on Monday. So I do hope you continue to be well. I hope you are choosing your one piece of exercise a day wisely and sensibly, and don't forget to email me at mcooper@ilfracademy.org.uk if you have any problems with your maths. Take care.